G'day viewers. I'm going to draw a few pictures. Some people need pictures. It makes it probably more easier to explain things. Let's talk about space. Very interesting subject about what space really is. Why the speed of light is what it is. Some people will claim, they'll make erroneous claims that the speed of light is the rate of induction. Well, that's only half correct. The speed of light is related to the impedance of space. And space, in the old terms you'd be calling it ether, but it's space. That's what we're in the space age now, so we'll call it space. Space is a low vacuum, it's not a complete vacuum. And I'll argue that space is made up of a virtually untold and incalculable number of tiny particles of both positive and negative charge. Some of you might confuse with this the term axions. Axions are theoretically particles way smaller than neutrinos. Well, I'd like to even go down another order of magnitude to subaxionic particles of positive and negative charge. And these particles are real, and we can prove this by different physical phenomena in the universe. Now, because they're real particles and we don't have the technology and we only have the basic understanding of their fundamental principles, but because they are real, we can see their effects on the universe. And there's another highly contentious point, is the universe. What we see of the universe we term as the observable universe, and that means that we can only see a small portion of the entire universe, and universe means everything. There are regions beyond the observable universe. We know that because we keep seeing entire galaxies accelerating into this our observational barrier. So once it's a certain distance from Earth, we can't see it anymore. Not with all the technology to man, we cannot see. It's like a wall. You cannot see through that wall. So we get away from that Big Bang theory, because that does not explain what's beyond the wall. There is way more out there than I will ever understand in my lifetime, and anybody on this planet. It's just beyond our reach. So what we've got to do is concentrate with what we can see and deal with. So getting back to these subaxionic matter, this could be the dark matter, or a composition. It could be part of the dark matter that we can't see or detect. And when these subaxionic particles get together, they can form things like quarks and not quarks. Now, I believe the standard model of particles, I don't believe it's complete. And what I also believe is there's, well, to quote Einstein, he said, energy and matter are two different manifestations of the same thing. So that's all we've got in this universe, is matter and energy. And of course, some people don't believe in antiparticles. Well, I can make them. I can make antiparticles with a small accelerator And yes, I do have one. I actually almost have two. I want to combine the two together, see what happens then. According to some theories, I'm going to get some pretty crazy results. But let's just focus on what this is all about. This is all about gravity. I didn't really want to do physics videos as such because there's too much argument, and you know there's too much make-believe going on. And you know, when I was 19, people were calling me a mad professor, and I objected to that because I told them I wasn't a professor for a start. Anyway, we'll get back to these two objects. These could be two moons, two planets, it doesn't matter. It could be the sun, it could be a planet. This is all very relevant. Now, I've heard semi-valid theories where they get most of it right, and they get to the edges, and like quantum loop gravity, that looks good, and you examine it, and the closer you get to it, it starts falling apart. And trust me, I've taken a lot of time to study everyone's views on gravity, and what, you know, this person says this and this person theorises that, and they can prove this. I can prove a lot of things with simple gyroscopes. You can prove the rotation of the Earth, and you know, people that believe in flat Earth, you know, you've got a valid point. If you live in the one spot and you've never been anywhere, you'll see the sun magically come up in the same spot every day, and your Earth is flat. But if you step back, the further you step back and examine it with more credible evidence, you soon discover that the Earth is round, and then you'll go, some people will argue that, and then the more evidence you get, the more accurate your measuring systems, you find out the Earth is an oblate spheroid. And then as you progress a long time, you discover that it's not a perfect oblate spheroid either. Oh, there's about a 10-metre dip in the northern hemisphere. Oh, what's going on there? There's gravitational differences. Now see, a lot of people think that gravity is a constant on Earth. They think it's constant. Well, I feel the same. You wouldn't be able to perceive the differences, but gravity fluctuates. It stays relatively constant, but it fluctuates. And it fluctuates due to external influences to our solar system. For example, they said last year our Earth actually sped up, and this has encouraged me to do a frame dragging experiment. If the Earth sped up, that means either it was to do with the planets affecting our Earth, but more than likely a black hole was cruising by our, or we cruised by a black hole. It's a relative perspective, but we suffered a differential decrease in gravitational interaction between the two bodies, i.e. the bodies of our solar system and the bodies of the black hole. Now, I'm only speculating that, but that gives you an idea of the theories that I'm looking at. We're looking at frame dragging. That will be my next experiment. So getting on to gravity, we've got two different bodies here, and in the centre, if the two bodies are identical in mass, the Lagrangian point will be in an equal distance from either body, i.e. in the middle. So in the Lagrangian point, you're not getting pushed this way and you're not getting pushed this way. You're in limbo. Now, I've poo-pooed a lot of ideas, and I've had to modify my concepts and thoughts. You know, people say, what is a field? I made a video of what is a field, and I stick by that video, but there's additional data, additional information that we have to place in those definitions. And if you want to look at a granular view of the universe, the entire universe is made up of particles and antiparticles and stuff we can't see and stuff that we don't understand, but nonetheless the fact is it's there, and we can see through the actions of those fields and particles with each other and planetary and galactic systems. But let's get back to gravity, and it is my proposition that a gravitational field is like this. It's supposed to be circular. I go there, I go there, I go there. So the two curves balance each other out. Their intensity and their interaction with any mass at the Lagrangian point cancel out, so there's no net pushing either way. It is not possible for anything to be pulled in my theory, right? We're talking about curves, mathematically plottable curves, and how they interact. Now, how this body here interacts with this is the field here will be like this, and this one here interacts there. Now this field, let's just draw it coming that way, right, and that one's coming this way. These are just arbitrary directions. Now these fields must be composed of fine structured particles. Call them force bits, call them gravitons, call them whatever you want. The preferred term for a gravitational field will be a graviton. Now, the gravitational field moves out at the speed of light, yeah. These particles do not move at the speed of light. Whoa, two different things. A train is doing 100 kilometres an hour, 60 miles an hour in one direction. So, okay, that's your speed that way. But inside that train, you've got people running around at, you know, 3 miles an hour, 5 kilometres an hour. So, this is the train. The train is the propagation velocity, and this is the internal velocity. And we'll get to this. We'll talk about pulsars and escape velocities. I recently studied orbital mechanics for a little bit. It helped me understand and make a slightly different perspective. And we can solve Newton's spinning bucket of water. He wasn't spinning it around his head, he was spinning it like on its axis. And we can see that that is a great demonstration of frame dragging, because it should have stayed flat, but it didn't. Anyway, this all relates to gravity and anti-gravity. The net force on every particle inside this mass is, here's the centre point of the second mass, all these points, every particle in this mass will point to this point, the centre of the second mass. So you've got, well, depending on the number of particles in the first mass, you've got quadrillions upon quadrillions of force vectors pointing to this, and likewise. Now the rule is, if we made this mass here a lot smaller, the rule of the interaction is the gravitational interaction between two masses is only as great as the sum of the smallest mass. So your Lagrangian point here now moves proportional, it will be here somewhere, right, much closer, because this field here is getting smaller as it moves away from the centre of this mass. So we've got a little tiny force there, and here we've got the matching force which dictates where the Lagrangian point is. Now some people say that the gravitational effect of our sun only extends for 2.5 light years. Yet our sun has been existing for almost 6 billion years. So I would argue that the gravitational field of our sun is almost 6 billion light years away. Yet it's because it's halfway between here and our neighbouring star is about 2.5 light years, and then we have the solar Lagrangian point in space where the forces are balanced out. Now this has a lot of relevance to magnetism and gravity. See, magnetism, gravity and light, to paraphrase Newton, they are all manifestations of motional forces, and we can call this force that acts on any mass gravitational motive force, GMF. Then you have, so I'll write that down, we've got GMF. You've got electromotive force, which is EMF, and you've got magnetomotive force, which is MMF. Now, some people believe that there's only 2 plus 2 plus 2 or whatever. Just add one more factor into your theories and you'll be correct. So my argument is for the universe is 3 plus 3 plus 3. Now this will bring into a lot of people, Tesla fanatics, will go, "Oh, he said 369." I don't know how Tesla did it, but it looks like that's correct, 369. And my work in the last week, you know, I was doing some hypothetical thought experiments, so I can, you know, you've got to think about what you're going to do and what experiment you're going to use, and what you think the results will be, and it's not always what you think happens. Sometimes the results are quite unexpected. Now I'll give you a secret. I'll let one of the secrets out. I'm not giving you the whole thing yet. I don't want to, because I don't know what the ramifications of releasing this sort of technology onto the planet is. Are you going to blow yourself up with it? Are you going to make it military? I'd love to see it used for peaceful purposes, but there was an episode of the Twilight Zone where the aliens said to the humans, "You have a small talent for war." And yeah, we do. We're very warlike, and that's so negative, you know, running around killing each other. But I'm not going to give you the full answer yet, but I will give you some of my findings, and they are that gravitational fields, I'll write it here for you, Gravitation fields Now, what's a graviton? It's a form of a proton. Just like there's 3 different types of neutrinos, and yes, they exist, and in certain instances, depending on the medium that they're travelling through, neutrinos will travel faster than light. But in space, light is the sprint champion. All right? Gravitational fields consist of gravitons. I'll write that here. A form of photon. Now magnets, same thing. And the biggest thing I can tell you about magnets is they consist of, I don't think we can call them magnetons, I think there's already a, but let's call them magnons, right? So, a magnetic field consists of, now this is just my naming convention, magnons. Now the key here, I will put here a form of photon. But just with a different field arrangement. Gravitation, magnetic, and we all know that electromagnetic fields, I'll write it down, electromagnetic fields consists of photons. Right? And a photon is in itself a combination of an electric field and a magnetic field. 3 different forms or 3 different manifestations of energy. Gravitational field, magnetic field, electromagnetic field. You can have a magnetic field without electricity or without the electric component, and you can also have the electric field without the magnetic component. Now that may fly in the face of physics, but there are instances where this can exist. Okay, now getting back to this, escape velocities. My argument is the magnetic field consists of a whole bunch of these magnons, but they don't have the sufficient escape velocity. They're not energetic enough to leave the orbit of the nuclei that's where the arrangement of atoms and are causing the magnetic field. So you've got your atom like this, nuclei, you've got different electron shells, blah blah blah. Now my argument is you've got this magnetic field coming like this and like this, and if you could accelerate it enough, and I know that you've done experiments that prove this, but it hasn't clicked, it hasn't gelled in your head what's happening. You accelerate this magnetic field enough and get it up to light speed, and then voila, you'll have your little photons coming out the top and maybe the bottom. This work is all based on experience and actual experiments, and the solution to this is out there in the galaxy. You can see the physical evidence. You want to see accelerated magnetic fields, go and have a look at your pulsars. And it was over 50 years that my own grandfather told me that if you can understand the pulsars and how they work, you'll have solved everything. And he was correct. So you look at rotating masses, there's two types of movement in this universe, linear and rotational, and you can combine the two. There are also other manifestations of movements and forces, but you know, it's like subatomic particles. You will be able to manifest energy into a multiple manifestation of different particles. There's almost an unlimited number of particles you can create with energy, but none of them are stable except for the neutrons are stable. We're talking real particles, not these massless particles. We're talking real particles. These massless particles are force carriers. That's what they are. These are your force carriers. Yeah, so basically what we've done is just a few experiments, and they've given rise to this differing view. I don't call myself a dissident. I'd rather think of myself as an explorer, exploring the fringes of physics and analysing what's going where and how it's doing it. But yeah, this is just my my work and what I think is going on, and my interpretation of these experiments. So, in a nutshell, these photons are travelling at sub-relativistic velocities. That's why they don't escape the magnet. That's why gravitons are captured by mass, and gravitons and magnons interact with mass. Photons, not so much. These have different physical properties. But that's all for today. I'll let you think about that, or you can try and argue against it. It's getting a bit warm here. You might see I'm sweating a bit. But thanks for watching. If you like it, I'll be doing a few of these videos. I don't want to cover all the physics. I just want to cover gravity and what we're doing with it and how we're making a drive system. And the next video I do will look at the journey to Mars and how we can do it way more efficiently. So thanks for watching. If you like it, give us a thumbs up. If you want to see more, subscribe. I'll try and do a video as often as possible, but the one thing that is the most precious in your life is time. So thanks for your time, and we'll be talking to you next time. Cheers.